Welcome back to the Digital Revolution with Jim Kunkel, the podcast where we break down the technologies, the leaders, and the ideas reshaping how industries operate in the time of digital transformation. Today's episode goes straight to the heart of modern digital operations, the world where data never sleeps, systems never stop, and the difference between success and disaster can be measured in milliseconds. Think about that for a moment. A millisecond is faster than the blink of an eye. Yet in today's digital landscape, that tiny slice of time determines whether a fraud attempt is stopped, whether a streaming platform stays online, whether a global enterprise catches a threat before it spreads, or whether a customer abandons your service altogether. And behind all of that is one concept: observability, not dashboards, not logs, not alerts, but the ability to truly understand what's happening across massive, distributed, high velocity systems in an instant. And that's why today's guest is the perfect person to help us navigate this role. Joining me today is Todd Pearson, CTO and co-founder of Hydrolix, a company that has reimagined what observability looks like at a massive scale. Todd has spent his career in building systems where latency is just a metric. It's mission critical constraint. From global traffic networks to real-time analytics pipelines, Todd's lived on the edge where traditional observability tools simply break down. Todd, welcome.
Hey, Jim. Thanks for having me.
It's great to have you. So what I wanted to do in an openness is really frame everything and talk about the new reality of real-time everything. I think that's super important to start it that way. And really to set everything up is, milliseconds today really determine security, the customer experience, and operational resiliency. Todd, why are milliseconds so important today?
Well, I think, you said this, it impacts so many facets of the online experience. And so I think we spent a long time, waiting for pages to refresh and things like that. And now, as I think the rise of agentic workloads is certainly pushing people to think a little bit differently about what the experience is like with any online, service or product. And, the faster you can respond to something, for a lot of companies, seconds are revenue, and so I think they measure downtime, in terms of dollars. And so I think anytime we can get insight into a system more quickly, we can get to a resolution more quickly, and we can get to a place where businesses see, smaller and smaller impact. We're never going to live in a world and have zero problems, we're always going to have problems, but we got to get to a point where we can remediate them as quickly as possible.
And that thought process too, when we think of legacy, it was all about monitoring. We monitored everything. But today, what we really need is true observability, because right now, data volumes and also AI out there and other systems, everything's doubling like within 12 and 18 months. And we know that's going to accelerate where it might be every 4 to 6 months. So this conversation is really important that we're going to have today because, in 2026, we have so many AI-driven systems that are coming up online. We've got a lot more bot traffic. We're getting deeper into edge computing and also, too, real-time decision loops. So what I want to do now is talk a little bit about your background. And what I kind of encapsulated as saying for you is like engineering for scale before scale was cool. And what I want to understand is your early journey from, the kind of the engineering side of everything to really building systems to handle, traffic and volume and observability.
Yeah, for sure. So I've been in this industry, since before the term observability really existed. So my first company that I co-founded, InfluxData, that was back in, I think we started working on that in 2012. And there were tools that existed for doing some amount of like instrumentation of applications and kind of understanding a little bit at a high level what was going on. But a big reason we started building that company was that we saw this difficulty when we just wanted to get custom metrics, custom visibility into our applications to really start digging in and understanding what was happening. and we just couldn't find tools that did what we wanted. And so a lot of where InfluxDB originally came was just we needed a place to store this data, and nothing else really existed that would go to the scale we needed. There were tools like Graphite and stuff. So there were some things, but they were very limited in what they could do. And so really it just came out of a need, as engineers, like how do we build and observe these systems? And a lot of other people were, doing similar things at the time. And so we sort of saw that period of time where we were building those tools kind of lead into the modern, observability wave that kind of really started to pick up in 2014, 2015. And so, all of this kind of came from needs as engineers. Like we want to know what's going on. We want to be able to tinker and explore these systems. And obviously now it's 1,000 times bigger than it was when we first started.
Yeah, definitely. And, one aspect too that I find fascinating is, we always in the past would talk a lot about latency, but today, latency is costing companies money. What, in your opinion, or what have you observed out there for the cost of slow?
It's a great question. Every company is in a different situation. You kind of mentioned, is it, a streaming service that has latency or a disruption or something like that impacts advertising revenue? Is it an e-commerce site that goes down and they miss sales? And so most companies that are sufficiently large and dependent on uptime to drive revenue have some number anchored to, an hour of downtime costs us, I don't know, let's say $100,000 or $500,000. There's some number. And so companies have that as an anchor point, and they can think, if I invest this amount of money in my platform and it saves me, 20 hours of downtime a year, that's got a dollar value associated. And so every single one of these things that adds up in terms of latency. And now, you mentioned latency, but it comes in so many forms. Is it getting data out of your system? Is it getting data stored into a new system? Is it how long it takes for it to be queried? Is it how long it takes for it to be visualized? And then there's, MTTR. And so there's latency at every stage of this process when there's an outage or an incident. And so you want to try and shorten all of those because you're just adding it all up. So you want to know really how long does it take from something happening to the point where somebody on my team can see and identify it and begin making a resolution. And so, every bit of that latency just means more impact to that uptime number.
And with your current company, what was kind of the genesis? What was the maybe a pain point or something that you were looking to resolve out there? What was really the genesis or the founding reason for your current firm?
Yeah, so Hydrolix is we're focused. We're basically a petabyte scale data lake for logs is probably the easiest way to think about it. So we do a lot of work with customers that operate at the edge, through CDNs and things like that. So we've got a lot of companies that we work with that are in media, gaming, e-commerce. And we have a deep partnership with Akamai, who's probably the largest player in the CDN space. And so we do a lot of work with their customers as well. And a big part of it, our CEO Marty, he had been working at another company he'd started previously, and they were trying to do some traffic steering type software in the CDN space. And as a result, they were generating a lot of logs because CDN traffic is super high volume. And so at that time, they were just sticking it in a cloud service. And they were like, wow, this is actually a lot of data. It's very expensive to handle all this data. And so a lot of where Hydrolix came from is looking at pain points of the past and saying, this would have been 8 years ago. And I mean, it's obviously data volumes are even bigger now. And just recognizing that like every system that's running at scale is generating logs. It's just like a kind of a ground rule of observability. And so all these systems in all these different verticals are just generating tons and tons of logs. And so CDN is particularly interesting because that's the first place where a customer may experience an issue, first place that a customer comes in contact with your service, and where you can start to see some of these indications of a problem, whereas things further down the stack may take longer for an issue to emerge. But the trade-off, though, is that CDN traffic, because it's at the edge, is the noisiest of all. Every request goes through the CDN. And so, for every file that's downloaded, for every chunk of video that's streamed, you can see a log line that tells you how the system is behaving. And so a lot of the genesis really was looking at, hey, we've got this really interesting use case, but the pain point is that it's just a massive amount of data, and how nothing else can really deal with it. And so Hydrolix stepped in to basically look at the trade-off between, retention and cost and performance, and kind of optimizing all those things so that you can keep logs for as long as you want for these use cases, without the cost being insane, but also still letting it be fast. And that's where, you kind of, you're optimizing things that are fighting each other. And so a lot of the innovations we came up with at Hydrolix were, how do we keep it fast without making it super expensive?
Yeah, because I mean, when you look at observability, the challenge is that traditional approaches, in most cases, are going to break at scale. And some of the aspects of looking at this with enterprises is that you talked about here about the logs, the metrics, the traces, the events, and things like that. So why do legacy observability stacks, why do they kind of collapse when you're dealing with that petabyte scale and ingestion you were talking about earlier?
Yeah, I think one of the big things is that, for this use case, and, this goes back to my time at InfluxData as well, is, we're looking at data that we know is going to be very high volume. We know it's going to be time series data, meaning there's going to be a timestamp on every row, and the other data that you have attached could be, could be numerical, like metrics that we're observing. It could be strings like text identifiers about either a user or an application or a region. And so we're going to have these rows that are going to have a timestamp plus a lot of other data that might be somewhat arbitrary to the system. You're not always going to know ahead of time what the schema looks like. You're not going to be able to do planning. And a lot of systems that get used by default, things like Elasticsearch, and more commonly we're seeing ClickHouse, those are great general purpose data stores, and you can make them do a lot. But when you start to get to the scale that you need to be at for modern observability, you really see that those kind of things I was talking about optimizing for really don't work out well. And so you can run Elasticsearch at a pretty crazy scale, but it is insanely expensive. Same thing with ClickHouse. Like you could do a lot, but when you really start looking at optimizing for log data or metrics or traces, kind of the key observability pillars, you find that you really kind of need to have something that was built specifically with that in mind. And a lot of these other features that make these other systems great for a bunch of use cases are actually kind of detractors of having good observability performance and cost and things like that. And so that's where it becomes, you essentially have to invest in building your own high performance infrastructure at the storage layer, and that becomes a big challenge when you're trying to build a new observability product and scale it up.
Yeah, and I would imagine before your company, before your approach and everything, there were probably observability budgets that were growing faster than infrastructure budgets out there.
Yep. Yeah, and I think one of the things is that your infrastructure is roughly correlated to your growth and your expansion. You add more capacity as you have more traffic, but observability can very quickly grow exponentially. Like if you're adding more logs, you're adding more metrics, you're adding more instrumentation in the hopes of getting more insight, it's very easy to add a whole lot more data than you intend. And it's easy for that to kind of grow and not get checked, until you see your bill. Like, Datadog is a great example. Like it's got a ton of features, all kinds of stuff you can do, but it's metered. The more data you send, the more you pay. And I think some people get surprised because there are unintended consequences of, especially we talk about high cardinality data. So we're looking at places where fields have a lot of unique values. And so user IDs are one of these where is a common case. You want to be able to tie an event, a log, a metric to a user ID. But that cardinality, if you've got 10 million users, that's 10 million unique values. And that explodes the complexity of the data. And some platforms charge on that. And so you'll see that these unintended, it's an honest desire to be able to instrument this thing, but they don't realize with the complexity of the platform how expensive that can get. And so definitely you see some like rapid growth of the observability data that doesn't tie to the infrastructure costs.
So obviously with the scale of all the data, and you've got companies still out there kind of taking observability in a legacy way. What are some of the operational risk of delaying implementing what, for example, like what your firm does for companies out there?
Yeah, and I mean, and part of this is companies that are trying to step from. I mean, this is particularly hard for companies that have been around for a long time, where they've got lots of legacy systems in older languages. They maybe got. I mean, we've talked to companies in the past. Like I've run into companies that are large banks, large multinational corporations that have like literally thousands of applications doing all kinds of things. And so when you think about the task of going through thousands of applications, maybe some of whom the original author is no longer around, and you're thinking like, what even matters to monitor here? What do I even need to know about? Do I even want to touch this code? You start thinking about all those and doing it thousands of times. It's a huge effort. And so I think part of this is just that the longer you wait, the harder it becomes to go back and actually really deliberately take that initiative and go add instrumentation and observability to your products. And so that's one of those things where it's easy to try and move fast early on and defer it, but it gets more painful the longer you wait. And then then the downside is not having observability logs or metrics or whatever for a long time means you're missing some of these historical trends. You're missing some of these things that you can use as a baseline. And so it's anyone who's not up to date on observability in their systems, they're probably aware, and they're probably aware of the pain that's associated. And so lots of the kind of usual side effects, kind of like putting off the hard thing until you feel like you're going to get time to actually do it.
Yeah, that's perfect. Let's switch over and talk about the real world impact and the aspect of where every millisecond matters. And, based on, my research and looking into the topic that we're talking about today is, how milliseconds they can affect anything from fraud detection, bot traffic classification, content delivery network performance, streaming and media delivery, application programming interface reliability. So let me ask you this. Why slow observability? Why is it effectively no observability at all?
Well, so I think if you imagine, again, from our perspective, Hydrolix does a lot of work with like media and streaming companies. So, let's say you've got an event that you're streaming. We've helped, help Fox with the Super Bowl recently. I think you look at that from a perspective of a user. Let's say they're watching the game, and if you've got 10 minutes of latency, like some systems have a really long ingest pipeline before you can actually see the data. You're watching a dashboard, and then you see, this latency is really spiking on their view, or their application's crashing, or whatever the reason is that they're having a bad experience. But your data is delayed by 10 minutes. Well, you're going to go and try and fix this problem that a user's been having for 10 minutes, and they're probably already gone. They've already probably closed the application. They've moved on. The impact is there. And so in some of these situations, you have a really small window of time where you can actually fix a problem and still kind of like retain that user experience. And it's not uncommon to see systems where it takes 10 minutes before you can actually see the data that's been set because of the way that these systems are built to ingest data. And so, the goal for us for a situation like that is for, from the time the data is emitted from a CDN to the time we get it and ingest it and make it visible on a dashboard should be, within the seconds. And at that speed, then people who are in charge of that experience, they can make a change. Maybe it's a infrastructure change, and they can push more capacity, or they can split to another region, because some of this stuff is happening. It could be an actual like application error. It could be an infrastructure problem. There's all kinds of places where these issues could come up, and that insight that you get from kind of that real-time observability lets you dig in immediately and figure out where that's happening so that you can fix it. And in a system like ours, you could potentially have seen and fixed the problem before other systems will even have surfaced that there was a problem. And that's really where, when we're looking at these like live events where, user experience matters, advertising targets matter, that window, keeping that window as small as possible is absolutely critical.
Yeah, you were talking about with your company's ingestion pipeline, and you were talking a lot about with the compression of the data, indexing, and then storing data at massive scale. How do you enable real time queries on trillions of data, but also when you're dealing with so many different events that are out there?
Yeah, I mean, so it comes down a lot to just like the design of the architecture. Like this is sort of one of our like key principles is that data needs to be searchable as soon as it's received. And so there are a lot of systems going on in the background that take recent data and combine it with older data. And this is a relatively common design pattern where you're taking data and compacting it into larger and larger chunks as they get older. But kind of one of the key principles is from the moment we get that data, we need to store it in a format that's searchable. And so that's kind of a big deal when you're looking at these observability platforms and time series platforms. It's like, what can we do to make that possible? And it means kind of going back to what we were talking about with other tools like Elasticsearch, ClickHouse, et cetera. There are trade-offs we can make where some of those systems are designed to have certain transactional guarantees, and that we can trade some of those off because we know that the transactionality is not as important as the ingest and query performance. And so we can say, listen, we won't give you this guarantee, but we will give you the ability to have your data searchable in 2 seconds, whatever, or under a second. And so all those, like, really building an observability platform is just dozens of those small decisions and optimizations that make it possible to do really, really well for this kind of real-time time series data, that other systems, retain flexibility for more generic use cases. That's what makes them less optimal at the scale that we operate at.
So your key value is it able to store more, query faster, and you're going to pay less overall.
Yep, that's it. And that's sort of that whole. Those three things are sort of the bucket that we've optimized for, and that's really what makes Hydrolix in particular, but observability platforms in general. That's kind of everybody's goal with these tools.
And when it comes to legitimate bot traffic, how do you handle that?
So I think right now we're in a weird spot where we've gone very rapidly from bots being relatively easy to identify. They sort of had very specific characteristics that make them easy to pick out, to this world where anybody can sit down with Claude or Codex and crank out an agent that kind of resembles human behavior. You can you can adjust the randomness factors a lot more easily. Like it doesn't take the sophistication that it used to be able to build something that's harder to detect. And so right now a lot of what we're doing is hey, we store the data. Like, we don't necessarily know in real time whether you're a bot or a human, but what we can do is give end users the tools so that they can start to do some analytics. And we're starting to build more tools that do, heuristics on this traffic as we're receiving it, and look and say, hey, this pattern over the last couple minutes, this looks fishy. This doesn't look like what a human would do. And it could be time between accesses. It could be the order they look at pages in on a website. And so because we have that data now, because we've solved the hard problem of being able to store this data and make it available, now we can start to do some of that work and say, here are some algorithms that help us kind of pick out bots. And once we have that data, then we can flag it for those end users, and we can say, this IP address looks like bot traffic. You can choose to block it or not. And we can start to surface that stuff a little bit more quickly to end users, and then they can make those decisions about whether they want to, block or allow those requests. Because one of the biggest things that we're starting to see is it's becoming a kind of a recurring problem where bots, agentic workloads can drive significant infrastructure costs. And for a lot of these companies, they don't want to lose out on real human traffic, but they definitely want to do whatever they can as soon as they realize it to mitigate those extra costs for bots. And then, as a kind of a parallel unit of work, companies are starting to look for ways to do agent or bot authentication. And because we're moving into a world now where there are legitimate use cases that are bot driven, but companies want to be able to have a way of saying, okay, you're a bot, but you're an authorized bot, or you're here to do legitimate commerce. And I think there's going to be more and more places where we see that. And so there's a whole bunch of startups that are kind of rising up in this space. They call it like know your agent, KYA, but things like that where you still even need to be able to delineate between legitimate bot traffic and illegitimate bot traffic, and then human traffic. And so all these things are changing very, very quickly right now. But at the core of it, and kind of the whole reason we exist is a lot of that differentiation that you want to make comes down to having the data, having it accessible quickly, and being able to really like give those insights to the end users to make those decisions about what's legitimate, what's illegitimate.
Excellent, excellent. Now that we're kind of in the midpoint of 2026, let's talk a little bit about the observability landscape. There are trends that are happening that you're seeing. Also, your clients are, they're talking about what's important to them. So, what are some of those trends that you see that have sprouted up over 2026, and what might be coming down the road?
Yeah, I mean, you touched on this a bit earlier. Data volumes are going to keep growing. Moore's law or faster. There's a lot of stuff that's changed over the last 6 to 12 months, just in terms of how fast some of these tools are evolving and giving us new capabilities. But I think that's going to continue to be a kind of a requirement for every company. Is like this observability stuff is here to stay. It's super important, but it's going to keep getting harder, and the data volumes are going to keep getting bigger. So I think that's going to be a place where scale is going to be crucial. The ability for humans to get insights, I think, is going to continue to be relevant, but we're going to be moving into a phase where the ability for agents to get insights is going to be even more critical. And I think we're already starting to see people contemplate a shift away from dashboards, where that used to be the foundation for all observability. Is like, if I can't see it on a dashboard, it might as well not exist. And so, we had already gotten to a place where there was more data than you could graph. There was more data than you could look at as a human. But now, agents can do a better job kind of digging in and digging in and digging in, and they don't need dashboards. So things like MCP servers are obviously very handy. But being able to give agents access to your systems is going to be, I think, a lot more common. And as a consequence, we're coming back to the query performance and the availability of data. Your agents are only going to be able to go as fast as they can get the data to make the next decision. And so, we're already starting to see some folks in this space kind of push towards, data storage products that are kind of like built for agentic workloads, or that have query properties that are more optimal for agentic workloads. So I think we're going to see that trend continue. Obviously, also, there's a whole bunch of companies that are in the AI SRE space, and so I think more of these things that used to be a human looking at a dashboard are going to be moving towards agents looking at data. And I think that shift is just going to continue. And so I think there's going to be a desire to feed more data to the agents, but also continue to push that performance envelope.
And will that lead us to predictive observability?
Oh, probably. I mean, that's sort of been the dream, like, for a long time. We've talked about it for years and years and years. That's like, I would love to feed data into a system that just knows what's going on. I don't have to spend a ton of time configuring and tweaking alerts. That the system kind of has enough of a sense for what my system is doing and what's normal, that it can alert me to things as they change. It's still, from computationally, it's still a hard problem, but I think we're getting to a place where LLMs are pretty good at reasoning about data, and coming up with some standard things to look for and search for. And so I think we'll see more systems that do a better job. I don't want to say just like anomaly detection is such a vague and loaded term, but looking for changes in your data and then making the decision whether to alert you, if you want to give it the ability to go and do some sort of a run book, make some sort of change to your infrastructure. So I do think we'll see more. Predictive is also sort of loaded. Like it'll probably be more able to pick up trends that a human might have missed, and so might be predictive, might be able to find some things before they actually become an incident. But I think the hope is really just that incidents can be more quickly detected and remediated, and drive that mean time to resolution closer to zero.
Yeah, that is high value there. So for the business, for those business leaders that are listening to this podcast right now, when it comes to practical guidance, what should those business leaders, what should they do now?
Yeah, I mean, I think we're again, it's weird right now. Things are things are strange out there. I think don't shy away from traditional observability tools. We're still going to have this period of time, I think, while a lot of what we're building is still maturing a lot. So I think continue to invest in observability, but stay kind of on top of some of these things, like I mentioned, agentic SRE. That's a field that's developing quickly. And again, I mean, some of it is not much more than kind of a wrapper around some of these LLMs. So I think it's, some companies have invested more in the kind of the secret sauce. And so I think there's still a lot of work there to be done. But I think, experiment with these tools, even for, us inside of Hydrolix, we're seeing some folks shift more towards building with Claude as part of their daily workflow. We're seeing our SREs use Claude for building, scripting and doing a lot of kind of like SRE tasks. There's still humans obviously involved in a lot of the infrastructure management upgrades, things like that, because it's still very sensitive, but the automation and tooling is getting a lot better. And so, so just, keep investing in observability, but stay open-minded to some of these new tools. Cause I think, if the last 6 to 12 months have shown us anything, it's that, new models can give us like overnight a step change in capabilities. And so I think we're going to quickly see a point where, depending on how much you believe the hype, like Anthropic's been talking about Mythos, their new model that's going to be really good at finding security holes, flaws in software. I think we're going to see models that do better and better jobs at at detection of anomalies, at processing more data at scale. And so I think this stuff is just going to be changing super fast over the next few years. And I don't think we're far away from a place where you can do a lot more of this observability work in kind of a headless agentic way. I think it's not maybe 2-3 years from now. I think we'll be having a very different perspective on what a day-to-day observability platform looks like.
Yeah. So to close out this episode, let's talk a little bit about the future of observability. And I believe in my research that your position has been that observability, it needs to become the backbone of digital trust. Did I have that correct in my research?
Yeah. Yep. You got that.
And so when why, the question I would have closing this out is, why companies that master that millisecond level insight, why they're going to dominate the industries out there?
Yeah. Well, I mean, I think we've already seen that some of these LLMs and coding agents have made, building software has gotten less expensive. It sort of has been the trend over time as, new languages and compilers and tool chains to build software have gotten better and better. Now LLMs are just another layer on top of that. And so building the code is going to be less expensive and less of a moat. So it's going to be easier for companies to step in and compete and build feature parity with an existing competitor. But what's still going to always matter is the reliability of the service, the trust that you build as a brand. And I think all of those things, being able to do and deliver all those things, whether it's being delivered by humans or agents, data is the thing that's going to drive the ability to keep your system running well. There's no, in my mind, there's no part of this revolution that isn't still tied to data. And so, code's going to get cheap. Everything else is going to get cheap. Infrastructure is still going to be expensive, and observability is still going to be critical. And those are places where, if anything, we're going to need more infrastructure, more observability as this continues to grow. And that's the place where the companies that are being smart about their observability, that are investing in new ways to try and get data in more quickly, get insights more quickly, and remediate more quickly. They're going to be the ones that customers look to have the best experience that they're going to trust with their business.
Yeah, because observability is so critical, my challenge to everyone listening is to please, if you need to, start from the beginning and re-listen to this episode. Make sure you share this episode, and also too, do your research in observability, but also reach out to Todd and his firm. Todd, how can people get in contact with you, the firm, or where can they find information about what you do in observability?
Yeah, sure. So the company name is Hydrolix, Hydrolix, hydrolix.io. You can reach me if you want to shoot me an email directly, todd@hydrolix.io. But we're out there. Get in touch. Looking forward to seeing where all this stuff goes over the next few years.
I am as well, and hopefully, in a maybe 6 months, a year, you and I can get back together and see where things stand at that time. I'm really looking forward to see exactly more and more about observability, and also to the business leaders out there, the companies, the organizations that really take this and adapt it and run with it. So, everyone, I greatly appreciate this opportunity to have another conversation with you. Todd, thank you so much.
Yeah, Jim, thanks for having me.
All right, everyone, please make sure that you do share this episode. But importantly, the Digital Revolution with Jim Kunkel is on all major platforms. Please make sure you're following this podcast, and feel free to reach out through the podcast. There's information on how to send us a text, send us emails, follow us, all that kind of good information. So thank you, everyone.